Have you ever seen a real live dinosaur or dragon? You haven't, because scientists have determined that dinosaurs lived millions of years ago. And you know that dragons only flared their nostrils and breathed fire in fairy tales. But that doesn't stop animators from trying to bring both creatures to life on film. Using computer animation and motion geometry, artists take dinosaurs and dragons from science and fiction to the screen.
Go behind the scenes to see how the biggest special in Animal Planet history was created.
They transform geometric shapes using translations, or slides, moving a shape from one location to another without changing its orientation, size, or shape. Rotations, or turns, making the figure rotate about a single point or axis along a circle. And reflections, or flips, reflecting one shape to the other side to produce its mirror image. These transformations help artists build the creatures on screen with depth and the sense of motion, making the animals and their worlds look real.
We set out to make dragons as convincing as possible.
Let's have a look. Dragons flapping their wings and wagging their tails. Dinosaurs running, fighting, and craning their necks. Does watching all this make you wonder how'd they do that? Creating such detailed moving images on a computer can be broken down to simple geometric shapes and their transformations. How does this dinosaur walk across the Earth? The artist uses a translation to create the illusion of movement by shifting a shape from one location to another without changing its shape, size, or orientation. See, the shape, size, and orientation don't change, just the position. The transformation makes it look as though the dinosaur is walking. The same concept applies to the footprints it leaves behind. The artist has created a pattern of footprints by translating each one forward from one location to the next without changing its shape, size, or orientation. We can replace the footprints with triangles. See how the shape's location changes and nothing else? These transformations reinforce our perception of the dinosaur's motion, and before we know it, have us wrapped up in an animated world that seems real. Another technique of motion geometry that artists and their creatures really couldn't do without is called a rotation, or a turn. These dragons, courting one another by free-falling with feet clasped together, look like they're rotating in the air. That's because artists move the shapes that make up the dragons about an axis, creating the perception that they're actually spinning. See? Each simple shape rotates along a circle around the axis. In geometry, a rotation changes the orientation of a shape, but not its size. A flip probably makes you think of this kind of flip. But the term flip in geometry refers to producing a shape's mirror image, its reflection. In the world of computer animation, artists flip geometric shapes all the time. Looking at this early computer creation of a dinosaur, you can see that one side is the mirror image of the other. The shapes don't change, but their location and orientation do. They've been reflected to the other side. Can you visualize the reflection used to create this dragon's wings? Look closely. One can be made using the mirror image of the other, the one shape reflected over to the other side. Let's flip or make reflections of these shapes. Look at each reflection. The shape's form and size is the same. We just changed its location and its orientation by flipping it over. But notice that the square and circle still look the same. That's because they have a flip within their shape. See? We can cut them in half, and the halves are mirror images. They're symmetrical. Animators use these transitions all the time.
So once all these elements are combined, hopefully you will believe that you are seeing real dragons.
Realistic dragons and real-looking dinosaurs, thanks to motion geometry.